When you are standing before a mirror, you can find some interesting things. Your left hand appears to be right, right hand appears to be left. Suppose you place a letter A before mirror, then what you find? It appears to be symmetric. Test this with other alphabets. B, how it appears? C, D, E, and so on. Here you are finding that some alphabets in mirror appear symmetric, some are non-symmetric. You find that many objects around you are symmetrical. You see these objects are symmetrical as they can be divided in such a way that their two parts coincide with each other. In this topic, we are going to study about symmetry and different operations, different elements related to symmetry. First we discuss about line symmetry. Now see these figures. In this figure, if you fold along the dotted line, then what you can observe? You find both parts are similar. Similarly in this figure, if you fold this along this dotted line or this dotted line, then also you can observe the symmetry. In this case, if you fold this across this line, you can find the symmetry. Similarly in this figure, if you fold this across this line, then also you can observe the symmetry. In this case, if you fold this across this line, you can find the symmetry. These three figures have the symmetry as they can be divided in such a manner that two parts of the figure coincide with each other when they are folded along the line of symmetry. This line is called line of symmetry. Consider this figure. I am taking a dotted line along this. If you fold this along this line, can you find the same? No, it is not possible. And this object, this has more than one line of symmetry or more than one axis of symmetry. The dotted line which divides the figure into two equal parts is the line of symmetry or axis of symmetry. An object can have one or more than one line of symmetry or axis of symmetry. In this case, the line of symmetry is 1. In this case, 2 are there. Here more than 2 are there. And you observe some more figures, and this is having a line of symmetry. This is also having a line of symmetry. In this case, you can find more than one line of symmetry. This letter and this are having line of symmetries. And look at these closed figures. These are made from several line segments, is called a polygon. And these are polygons. Now if I consider these three triangles, in figure 3, triangle has equal sides and congruent lines. It is thus called a regular polygon. A polygon which all sides and all angles equal is called a regular polygon. Now if I see these polygons, if we consider these polygons, this is regular, this is also irregular, and this is regular, and this is irregular, and this is regular. Now you take this triangle. Can you draw axis of symmetry for this? Yes. About this line, it is symmetric. And about this line also it is symmetric. And about this line, it is symmetric. In this case, we are having 3 sides and number of axes of symmetry are 3. In case of square, the square is symmetric about this axis. And about this line also it is symmetric. The square is symmetric about these two dotted lines as well as along this line and along this line. Number of sides are 4 and it is symmetric about 4 axes of symmetry. And in this case, that is a pentagon, the number of sides is 5. And how many symmetric axes you can draw? This is symmetric about this axis. And can you find any more symmetric axis? No. Therefore, this is symmetric about one axis. In case of regular hexagon, you can draw symmetric axis like this. Therefore, we are finding the number of axes of symmetry are 6. From this we can understand that a regular polygon has maximum number of axes of symmetry. Suppose we consider these three triangles. In case of this triangle, we can draw more number of lines of symmetry compared to these two. That means a regular polygon is having maximum number of axes of symmetry. Now in this case, this figure is symmetric about this axis only. In this case, this triangle has no line of symmetry. Since it is a scalene triangle, no two sides are equal in this case. And in this case, it is symmetric about this axis. In this case, it is symmetric about this axis. In this case, this is vertical axis of symmetry and this is horizontal axis of symmetry. This is symmetric about horizontal axis as well as vertical axis. This is symmetric about vertical axis. Now this is symmetric about this axis. The conclusion is every closed figure with at least one axis of symmetry is called symmetric figure. And this is about the line of symmetry. Now we discuss about rotational symmetry. Now say this diagram. Now rotate the paper around the marked point for 180 degrees. Now rotate this by 180 degrees. Then what you can find? Are you getting the same? No. If you rotate this by 360 degrees, then you will get the same. Similarly, now take a paper, fold the paper like this. This is wind wheel. In this case of wind wheel, for every rotation of 90 degrees, you get the same structure. Thus, if you rotate a figure about a fixed point by a certain angle, the figure looks exactly the same as before. We say that the figure has rotational symmetry. Similarly, in this case of fan, if you rotate it by some angle, then we are getting the same. And we are rotating this about this axis. This is called a rotational axis, and this rotational axis is axis of symmetry. The angle of rotation for symmetry is the angle through which we have to rotate this to get the symmetry. In case of a fan, for every 120 degrees, we get the symmetry. The angle of rotational symmetry is 120 degrees. In this case, for every rotation of 90 degrees, we get the symmetry. Therefore, the angle of rotational symmetry is 90 degrees. The minimum angle of rotation of a figure to get exactly the same figure as original is called angle of rotational symmetry or angle of rotation. Order of rotational symmetry. The angle of rotational symmetry for a square is 90 degrees. Already we know that. If this is rotated by an angle 90 degrees, we get the symmetry. And rotating by 360 degrees, we are getting 4 times symmetry. Therefore, we can say the square is having rotational symmetry of order 4. Similarly, in this case, in case of an equilateral triangle, now this is rotational axis of symmetry. For every 120 degrees of rotation, we get the symmetry. By rotating this triangle by 360 degrees, we get 3 times exactly the symmetry. Therefore, the order of rotational symmetry of an equilateral triangle is 3. By these two examples, we can conclude that the number of times a figure rotated through its angle of rotational symmetry before it comes to original position is called the order of rotational symmetry. That means by rotating 360 degrees, how many times the symmetry repeats, that is called rotational symmetry. The order of rotational symmetry for a square is 4. The order of rotational symmetry for this triangle is 3. Suppose if I take a cube, what is the order of rotational symmetry for this about this axis? Yes, it is 4. And about this axis, it is 2. Similarly, if I consider a rectangle, in this case, if you rotate about this axis, what is the order of symmetry? It is 2. Line symmetry and rotational symmetry. Now we can conclude that some shapes are having only line symmetry and some are having rotational symmetry and some are having both. Squares and equilateral triangles, these are having both line and rotational symmetry. The circle is the most perfect symmetrical figure because it can be rotated about its center through any angle and it will look the same. A circle also has unlimited lines of symmetry. A circle also has unlimited lines of symmetry. Now in these figures, this is having a line of symmetry about horizontal axis. Now this is having a rotational symmetry. And this is having rotational symmetry and a line of symmetry. And this is having rotational symmetry. There is no line of symmetry. Suppose we take some alphabets. We take Z. Can you have a line symmetry for Z? No. What about rotational symmetry? Yes. About this axis, it is having rotational symmetry and order of rotational symmetry is 2. For this letter E, it is having a line symmetry about this axis, horizontal axis. One line of symmetry is there and it is not having a rotational symmetry. If you rotate it, you won't get the symmetric structure. In case of H, it is having a line of symmetry about this axis as well as about this axis. It is having two number of lines of symmetry. Now what about rotational symmetry? If you rotate this H, are you getting the symmetry? About this axis, rotational symmetry is there. How many number of times the symmetry repeats? What is order of rotational symmetry? You think about it.